Okay, high schoolers, this is just a quick little video update in chemistry since I've been away, students have been away for the past little bit. So let's just talk through this update, kind of 4 parts to it. So the first one is the quiz that was on Wednesday last week. So it's graded, it's in Power School. So you guys, I'll get back to you tomorrow. Oh, actually, I guess I can't give back because people are going to write it. So anyways, if you missed it last week, you'll have to write it in class this Friday. So that's March 8th. Okay, so just keep that in mind. It's part of a larger standard anyways. So right now at this point, I'm probably not going to do a reassessment on it because there's going to be a bigger quiz that's going to be related to it anyway. So don't worry about that. Okay, I did have a question about part of the simulation and the calculations that were shared yesterday. So I'm just going to talk about that a little bit. Some of you guys that weren't here, I think I will share it or did share it in Google Classroom, the first answers to the Airbag simulation worksheet. Okay, so look for that in Google Classroom. And then I'm going to talk about where we're at for this Airbag lab. So I heard from some of you that basically everybody got their volume worked out for the Airbag already. Okay, so the next part is the yellow paper and how it gets filled out. And then also there's a design and procedure section as well. So I'll talk about that. Okay, this limiting reactant, I'm gonna have to make a video for those of you that missed class on Monday, and you will get that fairly soon, hopefully later today as well, about how that works and that lesson. And I'll just print out a note page for you so you can just listen to the presentation and write some questions down that you might have, but I'll give you the notes for it. All right, so let's carry on. So let's look at the Airbag simulation. Okay, so there's a C and D part to the Airbag calculations, and it was right here. So somebody was just asking, like, how do you actually do this part? It says, in the second reaction, or has to remove all the sodium that is produced because it's kind of, reactive and explosive. So using reaction 2 above, determine how many grams of potassium nitrate that should be used, that should be placed in the airbag to fully react the sodium. Okay, so in the first part of the calculation, you determine how much sodium was produced, and now you have to use reaction 2 to figure out how much potassium nitrate is used to, what's the word I'm looking for? Used to, react all the sodium that was produced in reaction 1. Okay, so here we go. Okay, so from the B part, there was actually a mole amount of sodium produced, 0.69 moles of Na. Now, to figure out how much potassium nitrate you need, you have to work with the mole ratio of potassium nitrate to the moles of sodium in reaction 2. So that's like a 2 to 10 ratio, right? So it's 2 moles of KNO3 to every 10 moles of sodium in reaction 2. So when you multiply this out, you're going to actually get a mole amount of potassium nitrate that you need, right? So it's 0.769 times 2 divided by 10, which gives you this much in moles of KNO3, okay? And after you determine that, then you can actually determine the mass by using the molar mass of KNO3. So that's kind of the hint in terms of finishing C and D off. So if hopefully that will help you, but of course you can ask me in class tomorrow if you're not too sure how to continue on from that part of the reaction. Okay, I'm gonna go to the next part here of the lab. Okay, so this snapshot is from the yellow paper of the lab. Okay, so, or the lab paper that was yellow. So just imagine this all to be yellow. Okay, so if you can't imagine that, I'm doing my best to color it into you. Okay? All right, so you're asked to fill this in, okay? And above this section, actually, I was telling you what we're going to react in the lab, right? I was telling you we're reacting two things. We're reacting acetic acid, CH3COOH, and we're going to react this with sodium bicarbonate, NaHCO3. Now, it's this reaction. You have to figure out the products, and I'm just telling you, you can Google it. It's a very common reaction, and it's going to produce a gas that will fill your airbag, okay? Now, in the next step, which is what is kind of clipped in here, it says, how will you determine the volume of the zipper bag? And you already did that on Wednesday, so that's why I said completed already. But over here, it says, design a way to control a reaction, or how can you start it when deployment is needed while still trapping all the gas. So I'm just trying to get you to think about how do you mix these components together so that you can fill your airbag within 30 seconds. So you're basically at this point trying to figure out how you would mix acetic acid, kind of compound 1, and with the sodium bicarbonate. And this is aqueous. This is going to be a solid. Okay? So the point of this part of the yellow paper was just to get you thinking about how you would do the procedure. Not necessarily I want you to list out a procedure. So this is just about more of like a brainstorming phase for the procedure. Okay, but if you wrote out steps, great. I'll take a look at it anyways before you actually do the experiment. So, well, that's what this part was. Okay, hold on a second. Let me talk about the next part of this paper. Okay, now on the back side of this paper, you're supposed to actually do the calculations. And really, this is more important to me for this paper than anything else, because I need you guys to figure out how much reactant you need to produce the gas to fill your airbag. So hypothetically speaking, let's just say your airbag was 1.2 liters in volume. Okay, so that's how much gas you need to fill the bag. So you kind of have to go work backwards from there to figure out how much sodium bicarbonate you need and how much vinegar, or again, acetic acid, CH3COOH, that you need. Okay, so the big hint for this one is 1.2 liters of gas. There's a mole amount to that. Okay, so just remember that 22.4 liters represents exactly 1 mole of gas. Okay, and from there, if you can calculate the moles from this idea, then you can work backwards to figure out how much of this you need, and then the other reactant is the sodium bicarbonate. Okay, so hopefully that helps. You're eventually going to have to write a procedure for this, so as getting you in this step to list all the materials that you're going to need. Okay, so make sure you do that to fill out this yellow paper, and I think that will be the gist of it. So tomorrow I'll help you kind of work through all that, or just double check it to give you more direction. Okay, so the last thing that I wanted you guys to do for tomorrow was this actual procedure, like an actual step-by-step of how you're gonna, like, you know, measure the materials and react the materials to fill your airbag. Okay, so this is, I just want a step-by-step process. You know, it could be like 1 to 10 steps, whatever it is. Okay. And to do that, you need to have the calculations done from the previous steps. So it's kind of hard to know how much to measure if you haven't calculated first. The other thing in here is you're going to actually have to gather data. So I want you to, create a data table that you would make to gather the data you need in the experiment. Okay, so you'll have to also think about that one as well. Like, what does the data table look like? What are the things that I need to record and measure? Okay, so those are the major things related to the airbag experiment. I'm hoping to actually run this starting on Monday. What day is that? March 11th? Yeah, so I'm hoping for the first groups to go on March 11th. Okay, so just keep that in mind. All right, and yeah, I think I'm done with that. All right, so thanks for listening. I hope this video helps. Oops.